All right, we're just going to look at latitude. Where is 0 latitude?
The blue line.
I don't know.
This blue line right here. What is that called?
The equator.
Equator. If we were to look at 0, so we have 0 and we have 90. Which one of those is low? 0 or 90?
90.
Which one of those is a low number?
I don't know.
0. 0 is a low number, 90 is a high number, isn't it?
Yeah.
Okay, we have established that?
Yes.
So this is 0, so where would low latitude be?
Below that.
Negative.
Where would the low latitudes be? Which number was low, 0 or 90? 0, so where would the low latitudes be? Around the equator. So the low latitudes would be close to the equator where the numbers are low. Now the poles, this is 90 degrees north, this is 90 degrees south, what would those be called? Low or high latitudes? High latitudes because their numbers are high. So we have low latitudes and they get higher as we go out. Are we good on that? Okay, so now let's use some transference here. Silicon organisms like cooler water. So let's think. Where do you think silicon organisms are going to more rather be? Here or here? Why? Because it's colder up there. So we can say that silicon organisms are more likely or less likely to be found in high latitudes.
Low.
Yes.
More likely or less likely? More likely. High latitudes, cooler water. Silicon organisms like cooler water. So that means in the low latitudes, what are we more likely to find?
Calcite.
Calcite organisms because the water is warmer. And we actually have a nice little table.
I disagree.
So if we look, the blue represents the calcareous. And where are there more blue?
In the ocean?
In the cooler areas. And actually, if you think about it, if you've studied anything on whales, that's where whales go to feed a lot of times.
Feed?
Yep. Because a lot of whales eat these kind of organisms.
What do whales eat?
A lot of them will eat zooplankton. All right. We have 3 more slides, guys, and then we're done. So, here's a summary.
They did not cut this food right.
Well, if you don't know this, I would write it. So, siliconous ooze.
Well, I could have figured you up.
Guys, gentlemen. Siliconous ooze, remember, likes cool water. Calcareous ooze likes warm water. So let's think, where do we have cool water? Well, we have it seafloor beneath cool water, high latitudes because the water is cooler, and in upwelling areas because that deep cold water rises up. Well, calcareous likes warm, so they're going to be on the seafloor where there's warm water, so around ridges or volcanoes. They're going to be in low latitudes because that's around the equator where the water is warmer. However, remember, calcareous can't go too deep unless they're encased and transported. So we're not going to generally find them unless they're encased in clay or something else below 4.5 kilometers. So this is just summarizing what we've talked about. So you guys should be able to thoroughly explain these 2 diagrams now using some of these other words that we've learned. Did we get our basalt back? I see Brandon's hoarding the basalt, huh? It's not worth anything. There's an ocean full of it, so just transfer it to the ocean and you can get a bunch. All right. How are we doing, guys?
Yeah.
Are we pretty good on this?
No.
Yeah, no?
Negative.
Just by those comments, I can tell that you're doing all right. Okay, but I need to move on. So if you did not grab all this, either get it from someone else or look online Okay. So the next is hydrogenous sediment. So we've talked about lithogenous sediment and we talked about biogenous sediment. Now we have hydrogenous. So this you should already have. You should already have something like this written down because we've had this comment already in the notes. So hydrogenous sediment forms when dissolved materials come out of solution. So think about a glass of salt water. You let it sit for about an hour, what's going to happen to the salt? It's going to eventually dissolve out. Yeah. So that is called a precipitate. When something dissolves out of something else, that's a precipitate. So when the salt settles out of the water, it precipitates out. Precipitation, so this process can be influenced by three things, generally three things. First one, changes in temperature. So let's think of some things that we create at home that involve the changes in temperature, that involve us mixing something with water. Coffee. Generally, does coffee work if you mix coffee grounds with cold water? Not very well. What do you need to do? You need to change the temperature. How about hot cocoa? Like the powder. You can mix it when it's cold, but it works better when it's hot.
Soup.
How about, yeah, soup?
Tea.
Tea? Mr. Miller had one because he's a really big fan of Jell-O, but Jell-O? Generally when you make Jell-O, don't you have to heat it up, the water?
No.
Yeah. So, let's think about soup, guys. So say you have chicken noodle soup, because I think we've all had chicken noodle soup at one point or another. Okay, guys. Just listen, please. So, you have your chicken noodle soup, but you're not hungry. So you let, this is like your fourth bowl of chicken noodle soup. So, guys, so you let the soup sit for a while. Has anybody here ever let chicken noodle soup sit for a couple hours? What forms on the surface? Like this layer of broth or grease forms on the surface. That is a precipitate that formed due to a change in temperature. It formed because the soup got colder, so it's separated from the soup. So if you heat it back up, you can mix it back in. All right. So that is change in temperature. Next one is pressure. So there's a couple things where you have changes in pressure. Now, I don't know if anybody's done this. I've had one class, but when I was a kid, which was a long, long time ago.
Were you afraid when the dinosaurs came out?
I was afraid when the dinosaurs came out. I had to go hide in my cave. Anyway, when I was a kid, when would I get a soda, because I barely ever got soda when I was a kid. Anyway, I put it in the freezer to cool it off. So I got like a bottle of soda. I put it in the freezer to cool it off for a while. And then I noticed when I took it out, it was still liquid. It looked like a liquid. And then I turned the cap, and all of a sudden it was all ice, slush. Has anybody ever done that before?
No.
Yeah. What happens when you open up that cap? What do you get? You get a change in pressure. And when you have a change in pressure, things freeze and melt at different temperatures. So all of a sudden, with that change in pressure, my liquid froze, turned into a slush, because I had a change in pressure.
So right away when you open it, it changes?
It just automatically goes from liquid to slush, like an ice. Yep. Try it. It's really cool. I always wondered why that was when I was a kid. I kept like, what did I do? It was a liquid and that was ice. That was before I knew anything about chemistry. I just thought it was like magic. I was like, wow, cool. And then the last one, guys, is the addition of any like other fluids that might cause things to precipitate out. The ones that I really want you to know are these two. Changes in pressure and changes in temperature. Those are the two I want you to know. All right, and these are some examples. You don't have to write these down. But some examples: manganese, phosphates, your carbonates, metals, and salts.
What's that?
These, guys, these all precipitate out of the water and eventually will end up on your ocean floor. So all these can be mixed in with water, and then as they settle, they end up on the ocean ground. Okay? And the last slide. You didn't have to copy the last one down. This one, I want you to know these two things. Cosmogenous settlement comes from generally these two types. Microscopic space dust, and here's an example of a microscopic space dust particle. No, it's a microscopic cosmogenous spheru, which is a little piece of dust from outer space. Well, that's because it's magnified.
What time is it?
4 times 16.
A lot. I don't know. Probably like 100 times. And then the other one comes from macroscopic meteor debris. So like meteorites that we can see. Debris? Yeah, D-E-B-R-I-S. So, what are the two places that cosmogenous sediment come from?
Space dust and meteor debris.
Space dust and meteor debris. So if you think about it, I know. If only I was like invisible, you could see through me. That'd be cool, wouldn't it? If we think about it, are we going to have a lot of this sediment on the ocean floor?
No.
Not really. All right, so that is the last slide that you will have for sediments.
You can't see